Klaus-Robert Müller, Chair of the Machine Learning Department, Technische Universität Berlin. Machine Learning and Applications.
Okay, hello everyone. You don't seem tired. It's amazing. I'm so impressed. Okay, so I will talk a bit about machine learning today, obviously. Yeah, I saw that people have corrected the slides slightly. So a lot of people have used machine learning in their talks. They have used the word of machine learning, but nobody has actually said what machine learning is about. So intuitively, think about someone trying to learn something, like a small child. So the small child learns by examples. So you show, for example, a chair and a table and another chair, and at some point, the child will understand the concept of a chair. So of course, this is a bit intuitive, and I approach this more from a mathematical side. So we learn from data, which means that we have some data set given X, and the data has some labels. I'm explaining you classification. So there's data and labels in 2D, very simple and boring. And the idea is to distinguish between the red and the blue points, which is also simple. You try to find a function f, which you don't know, which tries to distinguish between the red and blue points. And of course, the function can be simple, and the function could be complicated as well. The data, you assume, mathematically, is coming from some unknown probability distribution. And the only thing that machine learning does is you try to do this process optimally. You try to find a function that generalizes on unseen data optimally. So that's the goal. And of course, it's not 2D data, but rather in many dimensions, and it could be a lot of data as well. So you can now look at what generalization means. So assume you're giving this data point. I guess most of you think that this would be a red point, okay? You have done some inference, and so you've done this inference by grouping in a very intuitive manner. But of course, I don't have the time to explain the math, and I think it's not very popular to do the math in public here. But you know that we can now distinguish between different classes, for example, different brain states. We can distinguish between different classes in images, and so on and so forth. So machine learning is a huge economic factor. We've heard that many times before. In Berlin, for example, my group has created a number of startups that have now more than 500 people in Berlin that work for them. So machine learning is used in autonomous driving, in speech recognition and images. Somebody used the same pictures as well. These are the state-of-the-art systems. This is to find the Higgs particle, to do neuroscience, and also to study quantum physics. So it is, in other words, also an enabling technology in the sciences. And for the last minute, I would like to show you an application in neuroscience. So here we decode brain signals measured with EEG and translate them via machine learning into control signals. And the machine learning does the decoding. So here you see a guy wearing an EEG cap. Signals are measured online, and the machine learning allows us to decode the human intentions in real time. So before we started with this, this is the Berlin Brain-Computer Interfacing Project, Gabriel Curios group, Benjamin Banker's group, and my group. People had to change their brain signals by learning for about 300 hours in order to be able to control the cursor. And we can do this in 5 minutes, given some data and the learning, the machine learning. So it's an enabling technology for neuroscience, but also for many, many other sciences. So Okay. So machine learning is enabling technology in the sciences, in industry, and it's in the heart of the digital future. And machine learning is one side of the coin in data analytics. The other side will be talked about by Volker. Thank you.